Hi guys. So far we have seen about the optical fiber structure of optical fiber, and we have seen about the numerical aperture acceptance angle. Now we are going to see about the classification of optical fiber according to material, that is composition of material, glass and plastic, and according to the mode of operation, and according to the refractive index. You know what is refractive index? I will tell you in detail in the latest slides. Okay, so now according to the type of optical fiber, according to the types, the optical fiber is divided into material, mode of operation, and refractive index. In the material, we have two classification of optical fiber. One is glass and plastic. Okay, so just see classification of optical fiber based on the material. Based on the material, we have two types. One is silica or glass fiber, another one is plastic. Okay, silica is the we know that sand is the primary raw material for the silica, and it is the composition. You just see core is made up of germanium oxide, silicon dioxide, and cladding is made up of silicon dioxide. So it is a silica material. Okay, so here see here core is made up of silicon dioxide, but cladding is made up of phosphorus pentoxide and silicon dioxide, a mixture of phosphorus pentoxide and silicon dioxide. So according to classification of optical fiber, it is divided into silica and plastic. Silica core have different composition and cladding have different composition. Now, according to the plastic, you just see core is made up of polyestyrene, cladding is made up of methyl acrylate. And see here, core is made up of polymethacrylate and cladding is made up of polymer. So this is these are plastic fibers. Okay. So according to the material, the fiber optic material, optical fiber is classified into silica or glass and also plastic. Silica, the core is made up of composition of material like silicon dioxide. Same way, cladding is made up of composition of material like phosphorus pentoxide, silicon dioxide. And plastic fiber, the core is made up of polystyrene. Cladding is made up of methyl acrylate. Core is made up of polymethacrylate, while cladding is made up of copolymer. Okay, this is according to the material. Okay, one is silica, another one is plastic. Next, according to mode of single mode and multi-mode. Mode in the sense it's a propagation of the light ray. Single mode optical fiber is designed to carry only a single ray of light. Okay, it transmit only one mode called monomode or single mode. The core diameter is very small. See here, 3 micrometer, and it requires high power laser sources. Advantage of the single mode optical fiber: high speed, large bandwidth. That means large bandwidth means we can able to transmit more data. Okay, it's a frequency range. We can able to transmit more data to a and it will the advantage of using single mode optical fiber, we can able to carry the data to long distance. Now just think single mode optical fiber. See the core is very small, so only one light single mode is passing inside the core. Here see, this is a cross angle view. See, core is very small, and here you can see the cladding diameter is high while core diameter is very small. So the core is designed to carry only one mode, single mode. Okay, so this is single mode optical fiber. Okay, and then you just see multi-mode optical fiber. The core diameter is larger while cladding diameter is smaller. Here the core is designed to carry multi-mode, different modes. Okay, see here the core diameter is larger while cladding diameter is smaller. So core is designed to carry different modes, multi-modes. So multi-mode optical fiber is used in most of the communications over short distance. So for short distance, we'll be using multi-mode optical fiber. So in the buildings and all, we'll be using multi-mode optical fiber. It will carry multiple light rays or multiple modes. The core diameter is larger, 50 micrometer, and it will allow different modes. So you can see the difference between single mode and multi-mode. Single mode core diameter smaller, where multi-mode core diameter is higher. Single mode only one ray is carried, but in multi-mode different rays are carried out. Single mode are used in long distance communication, while multi-mode are used in short distance communications. Just see, single mode and multi-mode. Core diameter is smaller, single mode, multi-mode, core diameter is larger. Higher bandwidth. We can able to transmit in single mode, we can able to transmit more amount of data, but in multi-mode we can able to transmit lower amount of data. So here, single mode long distance you can use, multi-mode short distance. And this is according to classification of refractive index. You know what is meant by refractive index. Speed of light in vacuum divided by speed of light in that particular medium, that is known as refractive index. So based on the refractive index, optical fiber are classified into step index fiber, graded index fiber. Now you see in step index fiber, see the here we have step index single mode. Single mode in the sense core diameter is very small, cladding diameter is higher. Here you see the diameter of the core is N1, refractive index of the core is N1, N2 is the refractive index of the cladding. Here you can see that both the diffractive index varying step by step. See here, it is varying step by step. Both refractive index are not same. Here the refractive index of coring and the refractive index of cladding varying step by step. So you are saying this one is a step index single mode fiber. Keep it in mind, for single mode core diameter is smaller, cladding diameter is larger, and here you can see the refractive index varying step by step. So we are saying this one is a step index single mode fiber. Okay. And then the next one is multi-mode step index multi-mode fiber. Okay. Now we see that multi-mode, the core diameter is larger, cladding diameter is smaller. Here also you can see that refractive index varies step by step. So this one is step index multi-mode fiber. Former one is step in the previous one is step index single mode because core diameter is very small, and here the refractive index varying step by step. So we are saying this one is step index single mode fiber. Now see here, multi-mode fiber, core diameter is long. Here also the refractive index varying step by step. So we are saying this one is a step index multi-mode fiber. So you can learn the advantages, disadvantages from this PPT characteristics I have given in the. Now I come graded index fiber. Now you see in graded index fiber, we have a cladding core. Now see here, the refractive index varying, it is not varying step by step. Okay, see the refractive index are maximum near the cladding and it is minimum near the core, on the axis of the core. This is the optical axis. It is minimum, the refractive index is minimum in the optical axis, and it is getting larger and it is higher between the core and cladding interface, and it is getting lower and it is become minimum at the axis, optical axis. So it is here, it is not varying step by step. Okay, so there is a curve, we can see the curve, it is